and then you'll get everything that comes out on this board that I write on. If we're in discussion, I'll usually pause it, and then I'll show you tomorrow, once I have them both up there, how to go on and look at the Moodle. So today, my goal is to talk about functions. Talk about functions, talk about domains, talk about range. Just like basic. You want me to leave the lights on or off? What? Don't fall asleep. Can you see your papers though? Yeah? Okay, and that is so dark for me to work in, but okay. Functions. When we have a basic graph, we always did y equals. Way back, we did your x values, your y values. We gave you your x's, you plugged them in, you found your y's. Then all of a sudden, somewhere around algebra, this kind of switched to f at x. But it still is your y. This is still your y value. Your f is just the name of your function. This is read x at x. We give a value of x, and we want to know what y comes out of this. What is the value of your function? When they ask for an n value, it's your y value. It's kind of like the black box theory. In this black box is y equals 2x plus 3. I send it an x, it does its little thing, and it spits out my y. So it is a function that's based on you giving me x values, your independent variable, and getting your dependent variable, your y values. No different than what you did all along. We just rename this differently. And we use this notation, this function notation, for your y's, for your compositions, for anything with your functions. We could name this function g of x. It would be the same exact thing, same process. Give me an x value, I plug it in, and I return the value of your function when x is 2. I find your y value, your value of your function, your g at x, g at x. A lot of times I say g of x, but g at x is the way we should pronounce this. We plug our value in, we return a value. We could call it an h function. It works the same way. You still have your set of independent variables versus your set of dependent variables. What we want to get to is that we will call all our values of x a domain. And we will call all our values of y a range. Okay? Now, when we describe a function, we say that every value of x will have one and only one value of y. This makes it a function. And you probably remember your vertical line test. So if I gave you a graph, and your graph went like this, I would say, is this a function? And you would say, it passes a vertical line test. Yes, this is a function. Because every value of x is assigned only one y value. So what do I mean by if it's not a function? If this y value and I can make my graph go on and on. Does this pass a vertical line test? No. So this guy right here, when x is equal to 1, has this y value and this y value. Has two different y values. It's not going to be a function. It's called a relation. I can graph it. I call it a relation. I can probably find out its x's and its y's, and all the pairs related, or domain and range when I need to. But I don't have a function. A function has to pass your vertical line test, or this definition, every x is assigned one and only one y. Now you also learned a one-to-one relationship where every x has one y and every y has one x. The y's don't repeat. We're going to get to that when we get to inverses. today I just kind of want to keep it simple just for a function today. So we're going to know that every x has one and only one y. And we're going to call all the values of x a domain. And we're going to call all the values of y a range. Now, I kind of like to branch off a little bit and say there are two types of functions. There are discrete functions and there are continuous functions. A discrete function is this. I have specific individual points. I have specific individual coordinates. I have individual coordinates, discrete, they're countable. They do not connect. Those are discrete. When I pull out my domain, if I'm looking for the domain of this, what would my domain be? All what values? The x or the y? The x. So what are my x values? 1, 2, 3, and -3. And if I was paying attention, I'd put it in order. -3, 1, 2, 3. Okay? All the values of y are your range. So what's your range for this? One, all your y values. 1, -3, 4, 3. Okay. My x's, my domains, my y's, my range. Okay. A discrete set is a countable set. They do not connect. Okay. A continuous set will have the same points like this. They'll have these points, but they'll be connected. That's continuous. That means in between each one of those points are infinite amount of points. It's continuous. How we get our domain here, an easy way to get your domain and your range is to box this off. Put a box around it. I've got two endpoints of my graph here. Two endpoints of my function. Does this pass a vertical line test? Yes. So I'm function. I have two endpoints of my function. So when you're making your domain now, your domain says this goes from -3 all the way to +3. And anything in between. So in the past, you made an inequality like this. And if we had circles here, filled in circles, we had an equal sign. And you probably said x such that x goes from -3 to +3, including both ends. In precalc, we use interval notation. And interval notation, and you might have used this in Algebra 2 because the Regents does this as well. Interval notation says, let's get rid of this inequality. Give me the endpoints. If I'm including it, I give it a hard bracket. If I'm not including it, I give it a soft bracket. So my data is going from -3, including all the infinite points, to +3. And I'm including those two pieces. This is where we're going in precalc. This is our domain. We're going to use in interval notation. You can start out with your number line, you can start out with your inequality, but I need you to get to interval notation. Do you remember doing this last year? Yeah, because the Regents offered this too. Now, your range, this is a number line. Sometimes if it's easy, you can turn your paper and you can see where your lowest point and where your highest point is. I know from these, there's my lowest point, there's my highest point. So my range is going from -3 to +4. Okay? And there's my range. Box it in. This is my interval notation. Tomorrow we're going to look at some of your restrictions. Because your domain is your independent variable, there are some things that you cannot use, such as in a fraction, you can't have a 0 in your denominator. So if I gave you this, you would say, well, you can use any x you like, but you can't put a 0 in there. You can't divide by 0. So I can use any other number but 0. Now, back when you did algebra 2, you probably said real except when x is equal to 0. We're going to use interval notation. We're going to start with your number line. And we're going to say, can't use a 0. You can use anything this way. You can use anything this way. And anything that goes on indefinitely is infinity. We come from negative infinity to 0. We can't use a 0. Or we go from 0 to infinity. That is the same as saying all real except 0. Sometimes I know it's easier to write it this way, but we're going to lean towards the interval notation. It's in the top right corner. Okay, so we're going to spend more time working on interval notation. Did you do this kind of stuff last year, algebra 2? A little bit? Okay, we're going to work on that as well. I don't know what I'm doing here. I keep doing this. My board doesn't always cooperate with me. Probably the way I wrote work. Okay. All right, again, we talked about x being the independent, y being the dependent. The value of your function is your y value. The x is what we know, and we plug it in, and we determine what your y is. That's the value of your function. Again, we have discrete sets versus continuous sets. So if we took this set of data and this set of data is here. Let's just plot these points. We have 0, 1, 1, 2, 2, 5, and negative 2, 5. And we want to know, is this a function? Yes, because every x has one and only one y. The nice part about this is when you look at your ordered pairs, if you see the x repeat, it's not a function. The y can repeat, but the x can't. We're not looking for a one-to-one, we're just looking for a function. Now we pull out your domain. Your domain says all your x values, and it's kind of nice if you can put them in numerical order. And then you pull out your range. Now you notice the 5 repeats itself. So therefore, the range only needs to say 1, 2, 5. We don't have to write it twice. We only write it once. All the y values have to come out. And it's okay for this to repeat itself because look, this y5 is here, this y5 is here. It still passes your vertical line test. They're assigned to 2 different x's. I'm not looking for a one-to-one, I'm just looking for a function. It wouldn't pass a one-to-one because then it doesn't pass a horizontal line test. But we'll get to that when we get to inverses. Even though it's repeated, it still has one and only x assigned to it. Right? Now, if I made this continuous, if I took this and I connected this, then I want all the points in between. I want it to go from this x value to this x value. How would you write your domain for this? In interval notation. -2 to 2, hard brackets. What would your range be? One to 5. Good. 1 to 5. and all the pieces included in between it. That's the difference between a discrete data set and a continuous data set. Discrete, they're countable. Discrete, the number of books you have on your desk, the number of pencils you're holding in your hand, the number of friends that you have. Continuous, how many ounces of milk you drank at lunch today. How many miles you drove to work today. It could be partial fractions. It could be partial miles. So that's continuous. Again, when we talk about domains, take a look at your graph. If we graph this, this is a basic parabola with a little bit of a dilation in here. The x squared is your basic parabola. The 3 dilates it a little bit, stretches it out. So your parabola is stretched out like this, and we're going to look at all kinds of transformations. And the nice part about this, I think transformations make far more sense when we hit precalc than they did in Algebra 2, because they're thrown at you so quickly, and most of the times you end up, teachers tell you to put it in your calculators. We actually do this without a lot of calculators with our transformations, and they make far more sense to you. So if I'm looking for my domain, and I'm looking for every x that this could be, I really want to just test this. I want to say, if I pick this x, am I going to hit it eventually? If I pick an x out here, am I going to hit it? Remember, this goes on and on and on indefinitely, forever, up to the top. So if any x I pick, any x I plug into here, I should be able to get a y, right? So my domain has no restrictions. I'm all real numbers. And you probably just had to say, domain, real numbers. On your number line, it's any number. It's infinity, negative infinity to infinity. You always read your number line just like you read a sentence from left to right. So negative infinity to infinity will be our all real numbers. Okay? There's no restriction on your x. Now on your y, for our range, we notice we never have any negative numbers. If I plugged in an x of 0, I get a 0 returned for my value of y. I can use 0 or any positive number, because any number that I square has to be positive. I'll never get a negative number out of this. So my range says y is greater than or equal to 0. Think of your number line. And then translate this to interval notation from 0 to infinity. Remember, you read from the left to the right. This might be review for a lot of you, and this might sound a little bit new to some of you. Just another way that we gather this all together. Again, interval notation. Your hard bracket is if you include the number, inclusive. Your soft bracket, it doesn't include the number. It's usually an open circle on your number line or on your graph somewhere. The U to join the two pieces. So if we, I'm sorry? Oh, they do say the same thing. To include, and this says not including. Thank you. I'm the only one that caught that. Thank you. Not including. That usually is your open circle versus your closed circle. My typing mistake. So the easiest way to start this, if you're struggling with seeing your domains in terms of interval notation, is use a number line. Start with your number line, and all you need to give me is your critical value on your number line. You don't have to draw me a whole 1, 2, 3, 4, 5. I don't want to see the whole thing. Just give me your critical value. Whatever endpoints you see here. These are your critical values. Just your endpoints. I don't want to see the whole line. Your arrow goes this way, and it is closed. Start like this if you struggle with finding it. Read from left to right. You are coming from negative infinity, and you're going to stop at negative 3. Remember to read from left to right. I have kids in the past give me -3 to -infinity. It has to be in the right order. Read from left to right. If I'm looking at y is greater than 4, is it opened or closed at 4? Open. So how would I write this in interval notation? Or to infinity, is it a hard bracket or a soft bracket? Soft bracket. Okay? This guy, this is my and statement. This is my or statement. That's wrong up here. I knew that one for sure. -3 to 2. This one has an equal sign. It gets a closed-in circle. This 2 has no equal sign. It's open. This is my and statement. This is perfect for your interval notation. Your endpoints go here. If it's closed, open. There's your interval notation. Those of you that haven't used it or are not comfortable are going to become really comfortable. It's so much easier than doing inequalities. This one is a basic or statement. Here's my 7, my 10. They're closed. I can go this way or I can go this way. So my interval notation will say from -infinity to 7, or use the u to join them, from 10 to infinity. My infinities leave a lot to be desired because I write them sideways, from, like as I look at you, so my infinities sometimes don't come out very nicely. So those are the things that we're looking at when we do our interval notation, when we talk domains and ranges. Okay, I want you kind of to be on the same page. Again, in the beginning, I'm giving you what kind of data set is number 1, a discrete or a continuous? Discrete. So by looking at that, is that a function or a relation? It's what? So is this relation, does it happen to be a function? It is a relation, you're right. Is this relation a function?
Yeah.
Yes. Why would you say yes? Because no repeating x's. Very good. So this relation also happens to be a function. Okay. So we're going to pull out your domain. Your domain are all your x values. It's nice if you get them in order. If not, we're going to worry about it later. So -1, 1, 2, 8, 9. Your range. What's the range? 2, 3, and we only need to write 51 once. Was that okay that 51 repeated? Because it's still assigned to 2 different x values. It's not a one-to-one, but we right now I only asked if it was a function. So those are things that you're going to look at. Number 3, which relations are also functions? Is relation 1, is that a function? Yes? Every x is a unique x? How about relation 2? No? Why not? Okay, good. Repeating x values. The 13 repeats. How about relation 3? Yes? That one's good. So just to get you thinking domains, ranges, functions, and the rules here. Okay. Number 7. Is this a function? Yes. Why? Passes a vertical line test. Good. This is a visual one for us. It passes a vertical line test. It's still means that every x is assigned one and only one y value. It's just when we see it in a graph, it's a visual for us to drop a vertical line. What's the domain for this function? Oh, wait, say that again? Good. Negative infinity to infinity. These are all real numbers. And how do I determine that? I try any x. I come here. If I take x as 4, will I eventually hit this guy? Yes. If I take x as negative 100, will I eventually hit this guy? Yes. I look for any exceptions. I have none. So all real numbers. Then I do the same for the y. So what's my range? Again, it's the same. All real numbers. And we're going to use your interval notation for all real numbers. I know sometimes it's easier just to say all real, or a lot of them say R. The old way was R like this, all real numbers. But we're just going to use our interval notation. Okay, I want you to take a minute and find me the domain and the range for number 8. Okay, let's try. What did you get for the domain? Negative 2 to 2? Now, if this was like a solid dot up here, yeah, but it's got arrows that go on forever. And it's deceiving because it looks like we have a real narrow graph, but in fact, if I put the value way out here, eventually wouldn't I hit that, right? So those are deceiving because they have the little arrows there. So instead, what would you say? Good. Negative infinity to infinity. Good. How about the range? Say it again, Christian. Negative 2?
3.
3. Negative 3 to infinity. And should the negative 3 have a hard bracket or a soft bracket? Hard bracket. Good. It's just a number line. If you have trouble, take your paper and turn it sideways and see where the smallest y value is. If you need to start like this, y is greater than or equal to negative 3, start like that and then work your interval notation. My goal is to get you to go to interval notation and to see the difference between discrete and continuous. Is number 10 a function?
Yeah.
Yes, it is. What's the domain? Negative infinity to infinity. What's the range? 3. There's only one y value, 3. Okay, good. A horizontal line is good. Okay, so
Would it be in hard brackets then if it was just 3?
we said the y value was 3.
But like, you put it in bracket, or would it be like?
Yeah, you would just go like this. 3. Just 3. 3 is the only one you can use. So tonight for homework, you're going to finish